कोई बात नहीं है. It's okay, fine, do it. Well, come on, start. I'm waiting for you. I'm waiting for signals. I'm not getting signals so far. Why? No reason for that. Because till now nothing has shown. I think maybe something happens now, but no. Nothing is coming up. Live is indicated, but signals have come. But there's no indication that it has started. Where's it started? Oh yes. Good morning, everybody. Good morning from Engineer Suraj Singh, who is speaking from Bharat, India, on this day, April 28th, 2021, Wednesday. Pertinent talk of quality, talk of COVID, talk of engineering, talk of title being civil field engineering, designs, construction methods, contracts, AnnexSL, organization, communication, coordination. As usual, this is very important for me to share my views. I'm saying views, I'm not saying command with you people, so that we can combine with the combination, think of quality, understand quality is important in life, and it must be considered that without quality nothing can happen in this world. This is, for example, a certificate. This is another example of a certificate. This is another example of a certificate. This certificate, that certificate, this certificate. For what these are? Do you know for what these are? What these are for? Do you understand? This is for quality everywhere. If I have certificates of competency, say I am an engineer, civil engineer by education, by professional education, professional qualification, and certification. I claim, I notify to everyone, my my registrar, my enroller, body that measured my competency, that body notifies to people of world that this is my certificate of professional engineer, chartered engineer, fellow, or degree or diploma or whatever. Whatever one has got, that is certified. What does it mean? What does it mean? It means that I stand somewhere for something. When it is called professional education, what does it mean? It's only for sake of saying, or it means something. Profession means what? If you understand something, if you learn something, if you deeply learn something, if you move to advanced levels of something, very, very advanced levels, and you are paid for your work because of that expertise which you earn after working a number of years post your education. All this integration of your qualification, academic qualification, your practical experience, and your whatever else you do, including research. This string, this integrated string, can be equated to a kind of definition, and that is profession. This means an advanced study, or you can say further advanced study of some subject, of some field, of some discipline, can be defined as profession. Profession is not for everybody you can say is a professional. No. Professional doesn't mean making money out of work. That is called occupation. That is called vocation. I'm talking of profession where you adopt your life into, you devote yourself into. Profession means is a kind of knowledge religion, not faith religion, knowledge religion. When I say that I am a civil engineer or mechanical engineer or whatever, this means I have devoted myself to learning of that subject academically or by experience as well, and of course with my common sense and my brain power. This means it is more than religion, because religion is imaginary. Religion can't be proved. Religion is something we just believe in faith, but in profession, it's different kind of religion. It's proven religion. It's proven fact. or you can say it's proven. You have to profess something which you rely upon and which you know very well. Well, I understand that. So when someone is that level, someone achieved a level of attainment in some field, in some discipline, profession, that person is expected by whole world that that person has certain mark, certain graduation or competency, certain level of graduation of competency, and that competency must be seen, must be available, must be, you can say, done every time in work. It is done or supervised in work. Whatever contribution that person gives to society in forms of material, product or services, those must be based on quality and quantity. We cannot say quantity is higher, so there can be a compromise on quality. Otherwise, reverse is true. If quality is higher, lesser quantity can be digested provided it remains within marginal economy. Excess of everything is bad. Quality is defined, is profiled, is marginalized, and that definition, that specification, that constraints within which you have defined quality must be achieved. If we cannot achieve that quality, then we should stop calling ourselves belonging to that profession. We have no right to say. You must understand what I am saying. This point is very important. Just claiming that I am in profession of engineering or in profession of medicines or in professions of chartered accountancy or law or whatsoever, if I am unable to do work for quality in that profession, there is no meaning to name myself that professional. First of all, quality has become a joke all over the world. There was a time when there was no quality system, but there were serious people. They were people who used to value their respect, their honor, more than earning power of money. That time, knowledge was respected. People had serious nature. They used to talk seriously. But it has changed now. Every facility is available. Paper to mobile, digital conferences, webinars, and advanced life. I think there is nothing that is not available currently, keeping view current status of world development. But everything is available. Yes, computers are available. I can't say that maybe people write now. I have not seen people writing. I am not seeing people signing because it is computer, paper, it is digital, so no need of signature. Writing power has been lost, except maybe some school students write, probably. Writing power has been lost, and because information is available online or in digital form, books reading has also gone. It was a time in past, in our youth age, that reading was very important. It was considered a status. If you had a library in your home or you used to go to library, people used to say person is a scholar. He goes to library, spends many hours there. He sits on terrace and reads, studies. He goes to garden with book and studies because there is no electric current in home. Person was called studious. And of course, when you study something, you study whole day, books, or you write something whole day, you calculate something whole day, you shall get knowledge. It takes time, of course. If you study 15 hours a day, 10 hours a day, or in examinations you burn whole night electricity, that period was, I can say, intellectual period rather than now. Now I can't say this is an intellectual period because every material of study is available. One has just to search and one gets answer. Maybe reliable or not reliable, that is different issue. But whatever you search, this means you have only to search. You are a finder, you are a searcher. You are not knowledge applier. You may be having whatever level of degree. Saving those who already are aged, I'm not talking of them. I'm talking of youth who have very high degrees. You can say there is no degree a youth don't have except knowledge degree, except experience degree, except that they have no patience even to do first and then ask others what is that. Well, I would say my statement is not to criticize youth, but to expose facts. We have lost study procedures. We don't want to study books. We want to study only from examination point of view. In field, we say we know it. And also those people who are experienced in professions like civil engineers, mechanical, electrical engineers, and all other engineers who come first. I have not seen books written by them except by professors. Those books are meant for to fulfill objectives of studies for students. But professional books giving their background is, suppose a person works for 30 to 40 years in engineering field. Well, I don't see many books, frequent writings from those engineers. Maybe they are too busy, have been too busy, but even then, knowledge goes with them. It doesn't stay on earth. It doesn't stay somewhere. Maybe very few, hardly 1% could write. What I am saying is culture of reading has gone, culture of writing has gone, culture of competition has gone. What is left is, if you have passed some course, some study, some degree, you pass only because you want to make money. What package you shall get? Package is more important than knowledge. Business running is more important. If you are very well educated, you must get package, and that package means you have to serve business for others. You are not doing your business, but your knowledge is used for some rich man to become more rich. That's also a fact. Oh, I am doing this job in MNC. MNC means international company. This means they have already money, lot of money they are investing, and they are using you as material. They are using intellectuals as their material, MBA, engineers, and many others. They are using those for making multiplication of their money. So educated people in fact are materials to help those rich people who are already rich. Well, this is fact. And they with prideful attitude say, oh, I am working in this company, I am getting this package. Package of what? Package of salary, package of facilities, and not package of nation. People have stopped thinking for nation, they have stopped thinking of society. Oh, my package is so many lakhs, and I have a car, I have a bungalow. So material has ruled, you can say, quantity and quality. If you conduct analysis of life, synthesis of life, based on thinking, I can say, I will find everything is ruined, spoiled. If society is kept off education, you can take examples of many countries. England, I have seen some people can't even write. Of course, I am not talking of very well educated section. Same thing you can say for America, worse than England. Because what is happening now happened there long back. How society crumbled there long back is getting crumbled in our country. Nobody cares for seriousness. Sleeping people, sleeping lot. Thinking is only for earning money. Analysis and synthesis and thinking are done only for earning money. How to make more. And those who are interested in doing something for society, hardly 1% people, because they don't have any back, they only talk, or they use something. If you go and see photos or Facebook, or you won't find any explanatory writing. You won't find any knowledge dissemination on those pages. I don't see any intellectualism, use of those forums for intellectualism. Everybody has become intellectual otherwise. I have seen postings of engineers, young engineers, who want to do everything in one day. They can design everything in one day. They can show that they have done this and that. And they don't care what they are showing, what they are posting. They don't care. Well, it's also not good to criticize, pinpoint everyone all the time. Works are works. My seriousness stands here that engineering field at least must have quality system. I don't say they don't have, but quality system means guarantee that quality shall be achieved. That doesn't work now. That doesn't work now. Time has come that we have to change our attitude. We are unable to change. We are unable to change because we are status hungry. We are money hungry. We are hungry for something we should not be. If you see meaning of engineer or engineering, you will find that it is related to intellectualism. Engineer means a person who remains in genius standards. One should be genius. That term has come from certain language, that engineer or ingenious person. And what is the ingenious then? Ingenious means you must have capacity to think, to concentrate, to think on something, to reach its total study. We say total quality, so total study is also important. Total writing is also important. Total thinking is also important. And total conduct is also important. We have seen many projects. I won't find any project which is defects free or which doesn't have substandard works. Technology may be advanced, everything is advanced, machines are available. Even after that, it's difficult to find 100% quality work. And they will give excuses, so many excuses. Concentration has gone, I can say. Concentration is now relative. It's software. Software which has to be used as soft support. Actually, software has converted intellectual into something which is useless. We have started thinking so much for software that software is my teacher, software my solution, and mind, intellectualism is defeated. This is my very much serious issue. I am very much concerned about that. Whenever you see some posting, some design, something, they would say software says this, software says that. Are we living for software or software is working for us? Computer is a tool everybody knows to assist us. But state of its response is reverse. There is no contemplation now because templates are available. You can find templates on computers. They do their way and we think it's final. I have not seen people talking of formalization. Take stat, take this, take that, use this, use that. So where do we stand? How shall our professional developed minds work? On what way we are? Are we just machines now? Are we just robots? Whatever we are given, we do? Or we have certain reliability coefficient, certain analytical coefficients, something empowered with us for synthesis. We consider reliable only by ourselves, and because others are also like ourselves, they consider they are reliable. You buy whatever product in market. Product is available, it's very beautiful, it's performable, and every claim is there. It may be branded or not branded, that's not an issue here. You can buy branded also, you will find in 1 month is broken. It stops working somewhere. I have bought products and I have seen that. So what does it mean? Means you are just salesmen now, you are salespeople, you are not quality salespeople. Product is not guaranteed for quality. No product. You can see aeroplanes, there's defects. You can see cars, there's defects. There's defect everywhere. You can see whatever, you can see construction of structures, you will find defects everywhere. And nobody points out, unfortunately. You buy vegetables, you speak a lot. Oh, this vegetable is septic one, or this is 5 days old. You buy some product, consumable product, you speak a lot. But when you go to buy a car, you may spend 20 lakhs, 30 lakhs, 3 million, 4 million on that. Seeing at what? Seeing color of car, seeing seats cover, seeing whether steering is to your requirement or no. It's 4x4, 2x4. But you don't see that this is machine. This is not forever. You don't ask capacity of engine, what indicative horsepower it has, what brake horsepower it has. Very few people know this. Oh, this is very good, this car. You don't ask for efficiency of that car, performance of that car, because you are not interested in that. Even if it is written on the specifications, you don't raise questions. I want BMW, I want Mercedes, I want this and I want that, people talk because of status. They don't need it for their requirements, for status. And they spend money on that. Beauty is more important, status is more important than performance. They spend millions and millions on structures and houses. They don't ask for quality. Nobody asks, oh, my flat hasn't come yet. That promoter is a cheat. That builder is a cheat. I paid money, I'm not getting it till now. I didn't get till now. It happens, very common, because supply is much lesser than demand. Economy is reverse. It was one time. People used to stand in queue in DDA Delhi, to book their flats, and quality of Delhi DDA was rubbish. And now everywhere is rubbish. You go to private sector, you go to a multinational sector, you go to whatever, quality doesn't prevail anywhere. Yes, there may be percentage differences. People used to say government is that and private is that. Now I think both are same, there's no difference. Quality spelling has been forgotten. Quantity is remembered, because quantity is cost, quantity is profit, quantity is earning, and quantity, if achieved more and more, financial losses, risks are covered. Forget reliability. What is reliability? I don't care about reliability. I must make my money. I want to be top 10 in world in rich. They are more worried of being rich or poor. This means human quality is lost in richness or being in poor. Where is quality then? Question is, if you talk spiritually, am I living for money or money is living for me? Am I human being or I machine? My measurement can be done only in terms of money, or it can be measured in terms of my character and quality. Questions do arise. Who bothers? Nobody bothers. Very big statements, top statements everywhere. We are customer pro. Customer satisfaction is our policy. Which customer satisfaction is your policy? Only on papers. to show that you are quality pro, you perform according to compliance of ISO 9001 or Sigma. Is that only answer? You buy products from everywhere in the world now, everywhere. You can't expect and don't anticipate that it's quality. By chance you get some product, it may work well, but otherwise in general there doesn't exist any quality to that level. And quality of course is specified, it is restricted, it is limited. Even then we don't get that. Just like quantity is, quality has no wings. You can't get unlimited quality because sky is quality. Sky is quality, you can say. Express is limited. There is some method for everything. For everything. You buy something, some method is there, some restriction is there. They say within these limits, we are there for you. We are responsible within these limits and within these circumstances, within these encompassing conditions. If you violate that, if you go beyond that, because those are not in our controls, we are not responsible for that. If there is a voltage fluctuation, I am not responsible. And they know voltage is fluctuating everywhere. It fluctuates everywhere. But they know it, knowingly excuse is made. Okay, because of voltage fluctuation it happens, so I am not responsible. Everybody knows what exists, what conditions we work among. Everybody knows this. But they have to say, I am best. We are best, we are cheapest. Yes, you are cheapest, but in character. You are cheapest in your standards. You are cheapest in speaking truth. I can say. Your standards are rubbish. You are only interested in making money and then claiming that it's quality work. That's a fact. You talk to a student who comes new, graduate, engineering graduate, who comes new. I don't know what happened, where has level of education gone down. No standards. They just want to run behind our softwares. I am a design engineer, I am a structural engineer. How you are a structural engineer when you don't know any structure? You neither designed any structure, nor you worked on any structure. There is no evidence that you have worked, and you claim to be a structural engineer. Even if you have a doctorate, doesn't matter, you are an engineer. You have to work first. You have to produce something on independent basis, not on guide basis. You have not done anything. You want a title. That title is a responsibility. So who bothers you? That's what I'm saying. Overhauling is required. Quality everywhere means what? It should be everywhere. It should be in thinking. It should be in work. It should be in theory. It should be in practical application. And it should be in use as well. We say systems. What does system means? We say individual. What does individual means? And we say element. What does it mean? And others. What are those others? We must analyze all this. It's like when we learn counting 1 to 100 or more. And tables we used to learn. Pahara we used to call in our old times. Why did we study that? Countings and tables. So that we could understand something and use them. Not to claim them. No means of memory, but application. Application was more important. Now if you raise some question to some student, you have so many kilos milk you have to buy, rate of 1 kilogram is this, you have so many rupees, you go to shopkeeper, ask him, give me so much milk and take this money, tell me how many rupees you'll get back. That a student of 10th class cannot answer. This is our standard. They don't understand how application of mathematics is achieved. How can you apply something? If you can't understand all this plus and minus, this, spending money, where does mathematics stand then? I raise many questions to students. They can't answer. They're surprised with how it's possible. You are learning mathematics. You should know what is mathematics, what is plus sign, minus sign, how this works, what is sum, what is reduction, what is division, what is multiplication. If you can't do this, what's the meaning of education? Mathematics is basis of life. They should know it. There is nothing in universe that doesn't use mathematics? Nothing. You realize this fact. Nature is a system of mathematics. If there is no mathematics, we can't say there are 24 hours. We can't say there are 7 days. We can't say there are 60 seconds in a minute. Some relation has been derived and is being used. And that has been used for centuries and millenniums. So we have to understand these facts very well. Mathematics is basics of life, not language. Language is only communication. And we have to understand whole analysis like this. When I say systems, systems means our own system. We constitute that system. Nobody is coming from the sky to constitute for us. Already there is a constitution of system. There is availability of system, and that is universe and solar system, which have been working for times immemorial to ourselves. But systems that we do ourselves, those we should do well. We should understand them. We should understand requirement. We should understand what actually we expect of this system, and only on basis of those criteria we can devise system. It's our division. It's our application. It's our objective. What system we design, what system we implement. It's our own. And we don't be serious in that. We have to think about, if you cannot achieve something, there's no meaning in that. There's education system, but graduates are not to that mark. What's the reason behind that? There are works in field, but products are not to that mark. There are thousands and thousands of buildings being constructed, but you don't find any durability in those buildings. People want beautiful plaster, beautiful decoration, beautiful color, but if you see, there are cracks in everywhere. Structural cracks, other cracks. Why? That's what I'm asking for. Individuals are involved in that. This means either they don't know how to supervise or how to do the job, or they are not interested in knowing that. This is okay, I'm getting my money and that's it. I've seen people, many people, who want house built, and they want, I have this size of plot, to give us some drawings, we'll make it ourselves. They can make themselves. I have seen people say, give us some lines, I want to see how to set this, and I will make myself. I'll ask Mason will do that. That overconfidence kills us. Means you want to do something, you do not know ABCD of that. You want to do something, and that too through your own. Why you want to do that? Because you don't want to reside in that, occupy that project, that building, but you want to sell it, dispose it, or you want to rent it to someone else. This means others' life are not important to you. These people may die in that. These people, building may collapse. You don't bother about that. But you just want to make money. You want to spend money so that automatically it is augmented, or it may give you returns, good returns. If that is your objective, then I don't have any answer. You are not concerned. As an engineer, I am not concerned for you. I am concerned for structure as an engineer. Structural stability, structural durability, structural safety is my criteria, and not your tenancy, not your sale. That's not my criteria. I'm not agent of your sale. That's not my job. My job is that whatever I do, I design, it should work according to its intended use. That is my individuality. Of course, I know I am discarded, no problem. It can be. Those people who think are always discarded, because thinking is not loved by people. Very few people love thinking. People want to design to their own requirements. They don't think for others. Yes, in engineering we have to design according to requirement. There is no way out. We can't say that. I can't go against that. There is a procedure of design. There is theory. There is practical. Everything, and codes and thousands of code, not one or two code. And there are procedures. We do that. But that is done either through your own efforts or through software. That is done. But is that design, if achieved successfully on papers and not on locations or sites, in terms of construction, what does it mean? Can you say we achieved it? You cannot say you achieved it. It's bluff. What I usually say, a design, howsoever smart it is, howsoever standard it is, howsoever fine it is, whatever level it is, designers worked on that. But that is meaningless, complete meaningless, if it cannot be implemented, if it cannot be constructed to that way. And that's where quality fails. Performance is required, time is restricted, cost is budgeted. We have to keep every factor in mind, every area in mind. In management or organization, which are very important, which count very important, like cost, time, quality, procurement resources, and various other factors, which are risk-borne or risk-free, we have to consider all those factors. Quality is not one point, quality is not 2 point. Quality stands at every point, and options are there, alternatives are there, but you have to define them. You cannot close your eyes and move. No, it's not permitted. Profession says there is definition of everything. If something is not defined, it is not professional. It is, arbitrary. If something is not defined, this is not acceptable. No arbitrary work. Logical work, justified work, reasonable definitions. Because if it's not available as such, if definition is not available, limits are not defined, just like in mathematics, say integral calculus, differential calculus, integral calculus, say integrate this one from this limit to that limit, and that's what life is. We have to define within this range, you have to do this job, and you have to calculate cost on that basis. If you change our standard, cost is impacted upon. So risk is directly involved with cost. Means quality is related to cost. If your quality is higher standard, cost must be higher. If your quality is further higher standard, then cost must be further higher. And that's what we have to measure like this. Performance means defined performance. Time is related to quality and quantity both. So we have to, confine ourselves within these restrictions, within the limits, and we cannot change them once we agree. And then analysis is very general. So we can say, if you talk of quality, it's very big, very quality definition. Quality cannot be defined in one sentence. Yes, it can be understood in one sentence, but one has to understand what is quality in what project, what is quality in what consideration. Simply saying it is quality, but you have to define quality. If you can't define quality, it's meaningless. Define it first and then talk of that. And if you can't define, so you can't say quality works. Quality works means you have to work. Quality works means you have to see it works. It's not simply when you see documents of project, you will find all documents. Or in life itself you find documents. And we can't define them. We have to value cost, time, quality, performance, risk, safety, every factor, every criteria point that is to be realized must be under control. So quality is a kind of command, you can say. Quantity is a product. Quantity is amount. You can say if product does not have intended quality, I'm not saying quality, I'm saying intended quality. Intended quality means that was expected in writing, in expression, or in understanding. And that understanding must also be described somewhere in terms of analysis, so that if some dispute arises, that dispute must be resolved within those constraints. There can be no open quality system, nowhere it's open around world. Certain restrictions are there, margins are there, which must be clearly defined in every terms, or else disputes certainly would come, because those people who are interested in money, they know loopholes, and those loopholes can't be closed by designer. And if designer is intellectual, really, that designer must see pros and cons, and that is very big time consuming job, and those who are pragmatic in that, they can understand that. I cannot go on speaking whole time, but I'm just giving you some reference of quality. Every day something comes to mind and we should express, because I have seen quality is not defined. Quality is defined as if it's a title only, but title or quality is not required, detailed quality is required. I deal with engineering, I do construction projects I've done through my life, and I've seen very much descriptions of technical quality, technical requirements, technical bids and commercial bids. There was a time when one bid, now world has moved into some details, so technical bid is also a requirement. Technical bid means to ensure, to measure your value, to measure your skills, to measure your competency, whether or not you can do this job. If you are not qualified to do this job, why should one waste time with you to talk about cost? If you are not able to do that job, there is no meaning to discuss with you what shall you charge with. You may be whatsoever, you may be leader in industry, but if you are not having competency, leadership is meaningless. That is an important point. Yeah, I was somewhere, here if you see, I talked of this chapter 1, that was general. This chapter 1 was general, and that we talked of some, what's this happening here? Industrial development projects and process facilities are talked of in this. And just to define why I'm talking about this, industrial development is very important. We talked of the policy decisions we talked of in this chapter. Then we talked of facilities requirement, facility justification and feasibility, then facility justification, feasibility, and components. What components are available? What does it mean? And we talked of that, as well as we talked of LNG tanks, we talked of compressors, we talked of furnaces and others, many other stationery. Okay, we talked of FRP, GRP pipes. I think that was some supports also. We talked RCC, receiving basin, etc. Flare towers, pump houses. I was somewhere here. So let us go back to where we have stopped. We'll take somewhere little overlapping here, because that reminds what the piping, FRP we discussed, layers we discussed general, and also this. So pipe rack. Okay, we come on to pipe rack. Let us start from there. Pipe racks, I'm talking of industrial plants where tons and tons of structural steel is used, and hundreds of kilometers of pipes are laid, all class of types. Pipe racks means these are structures, overground structures, ground structures, above overhead structures. These are like platforms on which pipes full of materials, full of whatever these pipes carry, of course, and these pipe racks are used to run those pipes, and this is throughout you can say on projects. And when maybe I have some sketches to show, if I can see facility sketch 1, general records, I think some chambers, method statement chapters. I think I lost that. General facilities, petrochemicals. I like to show what pipe X is actually, that's more important. I just want to see where it is. Hold on please. Just need to see, because filing system on computer is very limited. I can't keep all time. Let me see where it is. I just wanted to show you that file, which is my career projects main. Where is it? It's there, I think. Yes. Quality, no, it's not here, I think. Career projects. Sometimes mind doesn't work, it doesn't remember. That's the problem here. I am not remembering where I did not. Oh, I'm wasting time again. I'm a time waster actually. I feel I'm stupid sometimes. I think I'm getting something here. No, it will not work. It's PowerPoint, it won't work. Oh no, it won't work. It's PowerPoint. Let me see if I can open this. I think you're seeing now, right? Yeah. You're seeing all this. You have seen this before also. Again, I'm showing you this because sometimes memory is very important. This is, this is a furnace. You can see structural design of this. Sorry. I'm sorry. You can see pipes are passing in through this building, a structural steel building or structural steel areas, and you can see this administration area, etc. Here you will see in this plant area, processing area, its pipes are not visible, but we can see further and see. You can see this plant, and also if you see these lines, see this LNG plant. If you see here, you can see this all pipes here passing everywhere. This is very big plant of LNG, and also if you go back, this point is that You can see here also around, there are so many pipes which are not seen in this directly. If you see this, you will find all these pipes racks here. You can see all processing areas having many pipes racks here. Your whole plants here, pipes and overbow everywhere. These are everywhere. You can see that, though it's not very clear, but hundreds of kilometers of pipes are here. You can see that. You see here. You can see this here pipe racks, and parallel to roads, sometimes crossing over roads. It's you can't even say how many measurements this way. Roads as well as pipe racks are there. I'm talking of these pipe racks. I'm talking of this, and that's where importantly we can say we have something here which you have to think about. You can see this going this way, and is what I'm talking about. So I close this file, and so that's memory. So these are used for required purpose of running piping from one point to other over ground levels. These are generally constructed of steel structures founding on RCC footings, but RCC frame structures are also used. RCC framed structures are also used. This means both structural steel and concrete structures can be used for running pipes, or can be used for pipe racks. Several kilometer pipes are run over these racks, supported and anchored to rack structure. These are fully accessible structures for maintenance purpose. Open steel or plastic flooring is provided on decking. This is very general. Now, heat tracing is an activity, very important activity. Heat tracing, we call heat tracing means it's the application on piping. In the application on piping carrying negative degree gas, minus degrees gas, much below than freezing point. Liquid gases is just like say LNG means, or some other gas in liquid form, gases in liquid form. Its application for carrying those gases in pipes. Otherwise, if we do not do this, we don't do heat tracing activity, material or gas flowing through those pipes may freeze and block flow within pipes. To protect that, heat is continuously maintained on piping to keep carried or borne gas in condensed form. This means it is applied on piping carrying minus degree gas, which may freeze during flow and block flow within pipes, for protection of which heat is continuously maintained on piping to keep borne carried gas in condensed form. It is very important item, and I can say if we go a little further and try to find heat tracing activity, it's also very important to get some idea, and that idea is very important. Heat tracing of piping system. Let us see if we can find some information here, because information is more important. Heat tracing of piping system. Let us see. If it's not it's very small, I will speak. Let us just a minute, please. Let me see where I am. I want to show. Let us print it and show you in form of tracing. This is taking time. What is piping.com, heat tracing, and I want to just take a look on this. I'll show you just now. It's heat tracing of piping systems, steam tracing and electric tracing. This is title of this work, and it is here, and say heat tracing of piping systems, steam tracing and electric tracing. You can see this now. In this heat tracing of piping system, types of pipe heat tracings, heat tracing types, heat tracing design steps, general requirements for piping, heat tracing system, description, heat tracing, designs requirement, there's so many things. Pipe heat tracing is generalized term relating to application of radiant heat input to piping systems from tubing attached to outside of pipe. Heat tracing is a process requirement. Pipes carrying higher fluid temperatures than ambient temperatures will lose temperature to surroundings. Insulation is a way to reduce this loss, but insulation is not 100% foolproof. So to make up that heat loss, small bore steam pipes or electrical wires known as heat tracers are attached to parent pipe. This system is called heat tracing of piping. Heat tracing serves various other purposes. What are those? It's like maintaining required temperature for process fluid, fridge protection, maintaining fluid viscosity, show and ice prevention. Type of pipes heat tracing. Heat tracing can be grouped into two classes: tracing of fluid heat tracing or steam tracing and electric tracing. Steam tracing of piping steam is circulated through tubes that run alongside pipes to keep process fluid at desired temperature. Other fluids like organics, glycols, etc. can be used as tracing fluids. In heat tracing system design, however, there are various advantages of using steam as heat tracing fluid as mentioned below. What it says, that is here information. Pipe steam tracing heats up process fluid quickly. It is pipe steam tracing heats up process fluid quickly. No pumping is required for steam. Temperature controls in steam tracing is high. Steam tracing example, this is given here. Electrical tracing. Other than hand, in electrical trace of piping system, an electrical heating element transfers heat into process fluid while running in physical contact along pipe length. Heat is normally generated in an electrically resistive element. However, other effects like impedance, induction, skin conduction, etc. can be utilized in electrical tracing. Electrical heat tracing is also known as cable heat tracing. This is a reference given to the website. Electric tracing it is. You can see that. heat requirement, ambient temperature, pipe material, maximum exposure and maintenance temperature, tolerance on supply voltage and voltage drop on feeding cables, service voltage, area classification, chemical environment, dosing margin. Three types of pipe heat tracing cables are used for industrial electrical tracing systems, and they are self-regulating polymer jacketed cables. Self-regulating polymer jacketed cables. These heat trace cables are suitable for temperatures up to 200 degrees Celsius and circuits lengths of up to 750 feet or 250 meters. Mineral insulated heat trace cables. Mineral insulated heat trace cables. Such heat tracing cables are used for a temperature of 60 degree up to 650 degrees Celsius and circuit lengths of up to 3,300 feet, or you can say 1 kilometer approximately. Skin effect heating system. Skin effect heating system cables for moderate temperature ranges and much longer heating circuits. Skin effect heat trace cables are used. They can be used up to 25 kilometer of length, and their rated temperature is up to 250 degrees Celsius. Controlling heat tracing's temperature for electrical tracing is very important. Controlling heat tracing temperature for electrical tracing is very important. Various control panels are used for heat tracing temperature control. Heat tracing system shall be suitable for operation on 240 volts plus minus 5%, 50 Hz, single phase AC supply, power supply to heater, tapes. Heat tracing cables shall be from local distribution panel, LDPs, located in field at strategic locations, load centers to be decided by contractor. However, main power distribution panel shall be located in switchgear room in a safe area. Piping heat tracing system. Let us see where it is. Hold on, please. I'm here. Hold on, please. Yeah. Let's say yes. It's gone. It's missing, I think. It's 5. Let's say yes. Okay. Piping heat tracing steps. Piping heat tracing tapes. Heating tapes. Heat tracing cables are also known as heat tracing tapes. Industrial heat tracing tapes or heating tapes should possess like following characteristics. Heat tracing tape should easily wrap around pipe or equipment. Heating tapes should provide intimate contact with pipe material for higher efficiency of heat tracing tapes. Efficiency of heat tracing tapes or heat tracing cables must be durable and long lasting. Now, to prevent damage during overlapping, heat tapes should have a burnout proof feature. Heating tapes shall be suitable for use in area defined in process data sheet. Corrosion resistant metallic must be provided for safe and hazardous area application, that is corrosion resistant metallic braid. In hazardous area applications, surface temperature of heat tapes shall not exceed 200 degrees Celsius. For valves, flanges, pipe supports and similar heat sinks, an extra heater tape length shall be provided. Heater tapes to be installed should consider easy maintenance or removal of valve pipe support. Heat tape surfaces must be cleaned before installation of heat heater tips, pipes. Advantage and disadvantage of piping heat tracing using fluids or electricity. The following figures show principal features of different types of heat tracing methods. And this is when heat tracing is used to ensure that system functions from a process standpoint regardless of climatic conditions. It's known as it's known as process control tracing. Process control tracing. Again, when heat tracing is used to prevent freeze up due to climatic conditions only, it is known as winterization tracing. So there are 2 points, that is process control tracing when heat tracing is used to ensure that system functions from a process standpoint regardless of climatic condition. It's called process control tracing. And when heat tracing is used to prevent freezing up due to climatic conditions only, it's known as winterization tracing. Heat tracing design steps. Following steps are followed to design a pipe heat tracing system. And I'm just giving superficial study idea. Calculation of heat loss from pipe or equipment. Adjust heat loss for insulation system. Correct that heat loss considering wind speed and additional safety factor. So this calculated value be used as input for heat tracing system design. Heat tracing system should add at least much heat to piping system to maintain required heat temperature in process fluid. General rules is steam tracing supply lines shall be taken from top of supply header to assure dry quality steam. This is requirement. Rules for steam tracing. I'm just giving you this for general knowledge. You should know. I'm a civil engineer, that's not my job, but just for increase. We deal with plants, we do so many things, and these terms are very important sometimes. Steam tracing supply lines shall be taken from top of supply header to assure dry quality steam. Identify locations for steam tracing supply manifolds and condensate manifolds early in design to reserve space in plant layout. This applies to non-steam supply and returns manifolds, hot oil, glycol, etc. So identify locations for steam tracing supply manifolds and condensate manifolds early. Now allow for an increase in insulation sizing to allow for tracers. Instrument application for heat tracing. Inline instruments can also be required to be heat traced as process condition dictates. In that case, piping need provide steam supply and condensate collection manifolds for all other instruments. Break between piping traced instruments and control system traced instruments match drawing break between two departments. Now heat tracing system description. Let us see if we get some information on this. It's important. Heat tracing system is saying description. Using various media such steam, hot water, glycol or hot oil, heat tracing is installed to protect piping, equipment and instruments against temperatures that would cause congealing or freezing of process fluids, interfere with operation or cause damage to equipment. Heat tracing design requirements. Daily, the average low temperature of coldest month shall be used to select low ambient design temperature that then determines degree of winterization protection required. No winterizing is required for water services except where a sustained temperature below minus 1 degree Celsius is often recorded for 24 hours or longer. Compressors, blowers and other mechanical equipment shall be specified for operation at low ambient design temperature. Heat conservation while heat tracing. Heat transfer cement may be utilized when a process line requires a high heat input and common methods of heat tracings are inadequate. Steam jacketing is utilized in specific cases where steam tracing with heat transfer cement is inadequate. Electric tracing is required or utilized when precise temperature control is required or where steam tracing is not practical. Thermostat setting for electric tracing should not be higher than fluid operating temperature. So these are heat transfer cement first, then steam jacketing is utilized in specific cases where steam tracing with heat transfer cement is inadequate, or electric tracing is utilized when precise temperature control is required or where steam tracing is not practical. Thermostat setting for electric tracing should not be higher than fluid operating temperature. Methods for winterization, so these are different ones. Winterization by circulation shall be provided where a sufficient power source is available to keep fluid circulating. Utility water and utility airlines in intermittent service shall be winterized by draining. Winterization by steam tracing is preferred method. Winterizing by steam tracing is preferred method when winterizing by circulation and draining is impracticable. Winterizing by electric tracing is utilized when precise temperature control is required or where steam tracing is not practical. Thermostat setting for electric tracing should not be higher than fluid operating temperature. Minimum tracing steam pressure shall be 1 bar. Maximum required is 10.3 bar. At maximum pressure, condensate shall be routed to plant sewer system. If condensate is collected, minimum usable pressure shall be 1.7 bar. Heat tracer description. Required tracer shall be determined by piping heat loss and tracer system. Tracer steam pressure found in heat loss chart. We'll see what is that, figure 1. Let me see if it's available here. Figure 1, we'll reach there. What it says, I'm just going through little to understand little. Required tracer size shall be determined by piping heat loss and tracer steam pressure found in heat loss chart. Minimum tracer size shall be 3/8 of an inch outdoor dimension tubing. Maximum size shall be 1 inch OD, outdoor diameter tubing for economy where heat loss chart indicates requirements for multiple tracers. A single tracer with heat transfer cement shall be considered. In using heat transfer cement, tracer of 3/8 of an inch and half of an inch OD tubing are recommended. If more tracer area is required, multiple tracers of 3/8 of an inch and half of an inch shall be used. Maximum tracer length shall be based on tracer size and steam pressure as follows. Steam pressure 1 bar through 1.7 bar. This should be steam pressure 1 bar through 1.7 bar. So this is given, specifications. Tracer length for heating tracer, all these are very much technical. And let's go to see tubing used for steam tracing, heat tracing. Steam tracing tubing material shall be in accordance with material specifications. So tracer shall be OD tubing, soft annealed copper tubing used with temperature of product line or tracing steam does not exceed 204 degrees Celsius. Above this temperature, dead soft annealed hydraulic quality low carbon seamless steel tubing shall be used where temperature of product line or tracing steam does not exceed 399. For aluminum pipe lines, carbon steel tracer material shall not be used. For aluminum pipelines and all lines above 399 degrees Celsius, tracer material shall be stainless steel. For conditions where tracer could be overheat, lines containing acid, caustic, amine, phenolic, water or other chemical insulation spaces blocks shall be installed with tracing pipes. Now this, I think, a very much detailed one, I'm not interested in that. So I think we should close this better. Purpose of this document is thrust block design. Okay, this is different one. So heat tracing, come back to our own file. We have referred to some detailed knowledge on heat tracing because it was very brief in this file. Maybe you get something important or at least informative, if not important. You must get something informative, if not important. That's point of view we are interested in. So it is now, where was that heat tracing file? Yeah, it's there. Pipe supports sleepers. Pipe supports sleepers. These pipe supports or sleepers, we call them. I'm talking of big pipes, not talking of 1-inch pipe or half-inch pipe. I'm talking of pipe, very big pipe, main pipes, you can say, water pipes. These are used for purpose of carrying pipes at near ground levels. These are RCC units located at defined spacing. RCC units are not pipes. I'm talking of pipe supports, sleepers. Sleepers, very big sleepers, these are very heavy. For direct support of pipes, steel structural supports are employed, remaining either connected or touching pipe by shoes over lengths at various spacing movement for purpose of sliding ratio. I repeat, for direct support of pipes, steel structural supports are employed, remaining either connected or touching pipe by shoes. Shoes is a supporting system over lengths at various spacing meant for purpose sliding also. For deciding locations of such supports and their anchorages, stress analysis is conducted that dictates required spacing, dimensions, you can say, and pipe structural based design. For a pipe of diameter not more than 4 meters, not more than 12 meters, spacing is adopted. For a pipe of diameter not more than 4 meters, I am talking dia, then spacing of 12 meters, more than 12 meters, spacing is adopted. Not more than, can't be more than. For other smaller size, smaller diameter pipes, spacing depends on standard length of pipes. Pipes that need sliding movement at joint are provided with such a base that allows movement of pipe in direction of its run. For that purpose, PTFE, usually call it polytetrafluoroethylene, PTFE, polytetrafluoroethylene, bearings fixed on steel plates, duly designed to withstand imposed forces, are provided. Below pipe supports shoe steel portion, a stainless steel plate is provided so that this plate slides over PTFE pads. Anchor sleepers, this now name is anchor sleeper. It's a big one, big sleeper. Big sleepers, thrust blocks, etc. are employed at various points, locations, depending on stress analysis requirements or results on en route piping. These are thick and voluminous structures requiring thousands cubic meter RCC for an individual sleeper connecting group of pipes. One pipe loop, on pipe loops, various kinds of stresses from all directions are imposed upon during operations or flows, which are resisted by these sleepers. Again, on pipe loops, various kinds of stresses from all directions are imposed upon during operations or flows which are registered by these sleepers. At change in directions of pipes routes as well as at T locations, big sleepers or thrust blocks are provided to resist resultant forces. These sleepers are constructed as RCC massive blocks. RCC massive blocks. Access platform, what's that? Access platform, just a minute, let me check if I can get some information about hold on please, sleepers. Trying to find something, I'm not able to find that here. It is something different, I'm not interested in this. Leave it blank. Okay. Welcome Mr. Sharma, I see your name now, Mr. Sharma. Thank you very much for your joining. So this is now access platform I'm talking of in addition to sleepers. Access platforms are constructed to access to an area above pipe level for maintenance purpose. You have to jump on that, through that some steps, and onto that platform you have to reach from ground. And EOT cranes are installed for such maintenance as well as lifting and placing pipes or other operating items in shops. These also met crossing or pipe requirements, and proper ladders, handrails and open floorings are provided for safe access. This is ordinary specification, requirements specification for access platform. Now RCC box culvert, what is that? The name is clear, RCC, but box culvert, these are included for various crossing pipes below roads, road crossings it is. Include for various crossing pipes below roads. Pipe culverts are also included wherever required for accommodation of spillage tanks. Embankments is constructed around to hold containing oil during spillage. For accommodation of spillage tanks, embankment is constructed around to contain oil during spillage. Pipes are connected to culvert's base slab using steel connecting arrangements. Enough space is allowed for maintenance purpose for free movement as well as for circulation. Let me check if I have some box culvert details here. Possibly I had. I will try to show you that one. Box culvert. If I can find that. Let me see sketches here. Method sketches here. Let me see. Precast covers. Box culvert. I see. Box culvert. You see, this is box culvert here. RCC box culvert. As a road you can see, and pipes crossing this way. Plan RCC box culvert, plan RCC box culvert single unit, and this is side elevation, and here you can say side elevation, and these are interlocked actually, precast one. Here you can say to go down, if you see in elevation we saw this in access box here. So here is to enter, these are supports for these pipes, and some pipe sleepers and pipes run here. There are steps to go in and down, and above this backfill and then road. This is box culvert, RCC box culvert, and this is that one. So you can see this sketch, interlocking RCC precast box units, culvert units, 2 meter is size lengthwise. Side elevation you can see the square section. This is that one, open square section within, and just for access purpose you will close later on the side elevation, and this is longitudinal elevation. This is a plan of that, and here is section, longitudinal section, crossing road is this way, and this is our box culvert for your reference only, that I wanted to show for clarification, and that's the important one. So RCC box culvert that I explained to you. Then receiving basin, I close that box culvert now. Unnecessary loading on this is no meaning, so I close this. Receiving basin, receive means something to receive. It's meant for collection of used water from processing unit. It's meant for collection of used water from processing units for intended purpose to further discharge into provided outfall at sea. It's basically means whatever water we use for circulation to cool plants, machines, etc. That water is used many times, and after that you have to dispose of that one back to sea, and that can be done through outfall structure. And to send it to outfall structure we have to use some basin, and that is defined here, receiving basin. This basin is also given a considerable structure size for collection water from various returning piping headers discharge, letting it accumulate and then dispose into outfall channel for further permanent discharge into sea, its original source. Various types of steel stop locks are installed to control flow according to provided capacity of channel and receiving basin, keeping abreast also relevant maintenance function of provided piping. Structure consists of RCC retaining walls in flow direction and RCC base slab. So that is this receiving basin. Flare tower. Flare tower you have seen on that, I think you have seen flare tower, no need of showing you again. It was there in sketch. It is seen that flare towers are required to establish a system to dispose of safely into environment released gases that cannot be used any further, keeping in view that composition effect of such disposable gas does not deteriorate existing environment. Let me see if I find something here in our Acrobat reader. Sometimes so many files are open, it's not convenient to open everything. I think it's not easy to open that. Okay, let me give it now. Let us keep it as it is, and we'll see. So flare towers are required to establish a system that dispose safely into environment, release gases from process area that cannot be used for any further. Keeping in view that composition effect of such disposable gas doesn't deteriorate existing environment, that we have to keep in our mind. Height such towers kept constable so that gases are burnt away into environment safely. Proper arrangements are designed for founding as well as checking the stability of such tall structures. It's here. I think I can show you that by chance I got it here. Let me see here. This flare tower is here, and I think this is here. This is picture manager rubbish. I think I can show you just now. Okay, I'll show you. PDF8 frontage. I'm just taking this sketch only. And I will just immediately show it now. Okay, it's come, and this flare tower. You can say it's come now. It's flare tower. I close this. So it's here, and say this is flare tower, this is pipes coming here, and this is quite high, flare tower here. You can see this fire here, and you can see disposal, burning of these gases. See image here, shadow here, shadow of this fire is here, and this shadow of this tower here. This is here called flare tower, and I think it's the R1. You can see that. This is your flare tower. I think it's clear to you. So I close this also now. Okay. So you have seen flare tower. Now pump houses. Pump houses are installed as large size and highly elevated steel buildings housing a train of various pumps, electrical equipment, chlorination plant, rotary drums, intake equipment, etc. Was that? Large size and highly elevated steel buildings housing train of various pumps, electrical equipment, pumps, electrical equipment, chlorination plant, rotary drums, intake equipment, etc. Piping is routed on ground vertically as well as horizontally on various types of supports having complex design. Various types of structural steel access platforms are built in for operational and maintenance purpose. Water is pumped into supply manifolds located just outside where chlorination is applied, and pipes are run to main route on ground up to various industrial users. Hundreds of thousands cubic meter RCC structures are built for supporting bases as well as for anchoring arrangements depending on pipe route dictating supporting requirement. Let me do it again 1 minute for you because it's very important. Pump house to understand as pump house how it works. That's also very important. You should have pump house, which is a very important one. And if I don't have that method statement, the facilities quality engineering GBS project design is not available in this. So I can say, let me go back to career projects and see what's that actually. I say pump house. I think I must see some. I think somewhere here. Let me see where it is. Let me directly see that pump house. Ethylene plant back package. So I can see here it is in a. Okay. Let us see here. Print it and see it as a name. You can see this plant, complete plant you can see here. plant. You can see here. You see this is C here, and this is intake, and this goes to this area, administration area, this warehouse area, and this is process area. So here we take water from there for purpose of this pump in. In this we are talking, is very important here. We're talking about this in case of this pump houses installed as large size and highly elevated steel buildings, I said before, housing a train of various pumps, electrical equipment, chlorination plant, rotary drums, intake equipment, etc. Piping is routed and ground vertically as well as horizontally on various types of supports having complex design. Various types of structural steel access platforms are built for operation and maintenance purpose. Water is pumped into supply manifolds located just outside where chlorination is applied, and pipes are run to main route on ground up to various industrial users. Hundreds of thousands cubic meter of RCC structures are built for supporting bases as well as for anchoring arrangements depending on pipe route direction dictating supporting requirements. And here we have to little, I have to wait a little till I come back because I can't keep it open. Meanwhile I can say that this is our components. I'll be back in 5-10 minutes. Just excuse me for that. So bloody many hours it is. Okay, just excuse me for that. I'll be back within a couple of minutes. Okay, gentlemen, I'm back here to be with you again. And here, it's talking of something which is very important. General components for other facilities, and that is here. General components for other facilities, and that is can say train. What's that? Train, string, common, process unit, sector. These are now. Train, as I said, it's a continuation of certain machines or equipment, vessels for processing. Train indicates separate process trains. Train indicates separate process trains. String indicates parallel process lineups of equipment within a train. So string plus a string, you may say, equal to train. Whatever is parallel to process, same processing, in same train, is called a string. A string means parallel process lineups of equipment within a train. So train can contain many strings, you may say that. Common, to be used for equipment that does not exclusively belong to one train, but to several trains. Severe, total complex, you may say, it's called common. Whole process plant, that may say, common, to be used for equipment that doesn't exclusively belong to one train, but serves total complex. Now process unit. Process unit, you can say slug catcher, for example. Slug catcher, condensate stabilization is called column. Flash gas compression, acid gas removal, dehydration, mercaptan and mercury removal unit, operating and regeneration. You may say other one, let us say sulfur recovery unit, sulfur degassing, clause off gas treating, off gas thermal oxidation, NGL extraction and fractionation overall. Refrigeration unit, LPG and ethane treating unit, field condensate treating plant, condensate treating, linen LOX storage and vaporization. Air separation unit, SGP reactors, syngas treatment, steam methane reformer unit, 1 SMR plus 1 pre-reformer, 1 into 50%, 1 SMR plus 1 pre-reformer. Hydrogen manufacturing, 1 high temperature shift and PSA unit with compression, 1 into 50%, 1 hydrogen temperature shift and PSA unit with compression. Heavy paraffin synthesis water distillation unit, catalyst activation and regeneration, light and stripper, light detergent feedstock, heavy paraffin conversion, synthetic crude distillers, high vacuum unit, catalytic dewaxing base unit. This I'm just giving you certain names of these plants, not to discuss with this because this is beyond scope of civil engineering, but just for information as a coordinational work, we should know something about them if you work on a plant, not technical details but some information, so that we can deal with other people, at least names of machine and their purposes, name of equipment and their purposes on that processing plant. If that is enough for us, I'm not going to details of this because this is beyond my specialization, but yet a cover up has been done so that we should know where coordination stands, what we have to do, because all these equipment must have foundations, must have bases, and we have to excavate for them. We have to install these vessels on those foundations, and we have to do maybe somewhere grouting, cement grouting or epoxy grouting between base of these equipment plates and concrete. So we should know at least what sort of names or drawings would have or designs would have. We should not be surprised to get that. And that's the purpose behind this. I'm not going into details of that. If I go into details of that, it will take. Now, reliability and availability. What is reliability and availability of this? Ultimately, we are talking system quality, and that's very important thing which we know about. And that's also we'll discuss, and project designs as well. So take care of that in this now. Now I'll close this one. This is not required purposes. You can see this plant I have already shown. All these machines are located in this area. You see these names which I have taken. This is process area, and this is administration area. So no machines here. This is warehouse, etc., etc. So no machines here, and these are intake machines, and this is process area, and of course this is supporting process area. So this I close now. No need of this. So reliability and availability, particularly system uptime are key project drivers. System uptime are key project drivers. A system's effectiveness model shall be developed for complex comprising base case, configuration of offshore facilities and gas to liquid, plant configuration, feed for project unit. When I say feed, means front end engine design, so that required overall system effectiveness of 335 steam days per annum is raised in a cost effective manner. Effectiveness model, that's the question here. What is effectiveness model? 335 stream days per annum. This is related. Systems effectiveness model be developed for complex comprising base case, configuration of offshore facilities and gas to liquid, plant configuration, feed for project units, so that required overall system of effectiveness of 335 of 365 steam days is raised in a cost effective manner. So this is what it says, 335 or 360 effect. You can say it's about 30 days less, so 1 month less, and 1 month less means 11 month efficiency is expected. Offshore development concept is based on direct transportation. Offshore development concept is based on direct transportation of produced fluids and gas from wells on platforms to shore without any offshore process or treatment. Just send offshore development concept with direct transportation of produced fluids or crude from wells onto platform to shore without doing any offshore process or treatment. From each platform shall be multi-phase carbon steel trunk line to common slug catcher. From each offshore platform shall be multi-phase carbon steel trunk line. Multi-phase carbon steel trunk line means main line to common slug catcher on shore. Means carbon steel trunk line shall be laid between platform to slug catcher. Chemical injection and regular pigging shall be applied for corrosion as well as hydrate formation inhibition to provide carbon steel lines. Chemical injection and regular pigging shall be applied for corrosion as well as hydrate formation inhibition to provided carbon steel 5. There should be no hydrate formation, so the inhibited. Produced fluids are received into slug catcher in upstream onshore facility. So this platform is offshore and slug catcher is upshore, is onshore, located onshore. Produced fluids are received into slug catcher in upstream onshore facilities. Onshore upstream means comprises slug catcher, that is number 1, slug catcher, condensate stabilization. So you receive this in slug catcher, stabilize, condensate stabilization, acid gas removal, you have to take out acids, gas removal, sulfur recovery called, and storage. SRU of gas, sulfur recovery unit of gas treating, or Scott unit, dehydration and mercaptan removal, NGL extraction and fractionation, final treating for finished NGL products, LPG and ethane testing unit, field and plant condensate treating. You can see a brief, brief on this. Onshore upstream comprises slug catcher, from there to condensate stabilization, acid gas removal, sulfur recovery and storage, SRU of gas treating or Scott unit, dehydration and mercaptan removal, NGL extraction, fractionation, final treating for finished NGL products, LPG and ethane treating unit, field and plant condensate treating. Onshore upstream facilities, condensate and water, kinetic hydrate inhibitor and corrosion inhibitor, slug catcher are separated. Onshore upstream facilities, condensate and water, kinetic hydrate inhibitor and corrosion inhibitor, slug catcher are separated. Water is sent to dedicated effluent treatment which caters for kinetic hydrate inhibitor and possible saline components. Condensate is stabilized and treated for sulfur removal, conversion for export sales. Condensate is stabilized and treated for sulfur removal, conversion for export sales. Wet feed gas, slug catcher is routed to gas treatment followed by NGL extraction and fraction. Gas treating facilities remove sulfur components, water, carbon dioxide and mercury from feed gas. Gas treating facilities remove sulfur components, water, carbon dioxide and mercury from feed gas. Treating of ethane recovery and treating facilities installed later, and LPG produces to further remove residual traces of sulfur, water and carbon dioxide. Well, they are just some technical information. Sulfur components so removed shall be converted to elemental sulfur for export as liquid sulfur. Onshore downstream synthesis. Okay, now what is that? Onshore downstream synthesis comprises gasification process. So many processes are there, you can see here, but these are not related to directly, only but just read them to know what happens for some information only. Gasification process means air separation units, heavy paraffin synthesis, catalyst activation and regeneration, water distillation, steam, methane reformer, hydrogen manufacturing. ASU's main purpose shall be to produce oxygen for use in SGP as well as also produce HP nitrogen for CAR unit, LP nitrogen and compressed air for use as site utility. In SGP, when say syngas be produced from natural gas and oxygen by partial oxidation. Syngas produce majority of syngas for subsequent conversion to synthetic heavy paraffin stream in HPS. SGP syngas requires treatment to remove soot and undesirable byproducts. In SMR, hydrogen-rich syngas shall be produced from NG and steam by a catalytic reforming process. SMR syngas has a higher H2 content than SGP syngas and is used to supplement syngas feed going to second stage of HPS reaction. Reaction HPS follows Fischer-Tropsch chemistry and produces significant quantities of processed water as a byproduct. WDU shall be used to strip hydrocarbons from processed water, which we subsequently sent to effluent treatment plant for recovery. CR unit shall be used to regenerate HPS reactor catalyst. HME use a high temperature shift on a part of SMR syngas and a PSA unit to produce an ultra pure H2 stream, mainly for use as a reactant in SMAR and liquid processing unit. Now, onshore downstream liquid processing, onshore downstream liquid processing scope comprises light ends, stripper, heavy paraffin conversion, synthetic crude distillation and stabilization, light detergent feedstock units, base oil units. Also in continuation, it has some knowledgeable part. And maybe I don't take full today, some only, because heavy dose is not good. High volume unit, catalytic dewaxing unit, base oils redistillation unit. These are just names you read or I read, doesn't matter. It's not, I'm not going to explain each. It's not in my capacity, just to read for you. Some systems here for information purpose. Only 2 pages, I think. 2 pages only. Then we will jump on to our total discussion, a specific one, and it's now only for non-shore downstream liquid processing. Non-shore downstream is that? Synthesis compromise of this is what you see. I did that. And also I'll take here this is also another one. I was talking yesterday about this, about use of supplementary cementing materials. I talked yesterday on this little. So we continue again for this purpose, because supplementing cementing materials, and here it is. So let us do a little on this. Downstream synthesis comprises of syngas. We have gone through here. We have done this. So we'll go the onshore downstream liquid processing. Onshore downstream liquid processing scope comprises of. That's what is important here. Onshore downstream liquids processing scope comprises light and stripper, heavy paraffin conversion, synthetic crude distillation and stabilization, light detergent feedstock units. These are just names, and because maybe we should know base oil unit, this onshore downstream liquid processing it is, then light and stripper, heavy paraffin conversion, synthetic crude distillation and stabilization, light detergent feedstock units. Base oil units, high vacuum unit, catalytic work waxing, dewaxing unit, base oils, redistillation unit. Then there are certain short forms here, LES, LDF, HPCSA, all these units shall also collectively refer to liquid processing unit or LPU, liquid processing units. In LES unit, water, carbon monoxide and carbon dioxide to be removed. In LDF, that's LES, first one, unit water, CO and CO2 be removed. In LDF unit, components shall be recovered and after hydrogenation run down to storage for sales as product. Remainder of HPS product shall be routed to HPC, where paraffin molecules are cracked and isomerized into middle distillate range components, which are subsequently distilled by SCD in LPG, naphtha, kerosene, gas oil and as an SCD bottom product stream. So this is a chain here, LES, LDF, HPC, SCD. So LES is defined here, then LDF is defined here, then HPC is defined and SCD is defined. I'm sorry. In base oil mode of operation, SCD bottom product stream is souted to HVU for further separation into vacuum gas oil, evaxy raffinate fraction and a residual fraction that is recycled to HPC. Waxy raffinate fraction shall be catalytically isomerized in CDW and then separated into products according to boiling range and viscosity in RDU. In no base oil mode, this is base oil I explained before. Now in no base oil mode, SCD bottom product stream shall be recycled to extension back to HPC. For no base oil case, throughput of complex is limited by capacity in HPC, one single maximum size reactor per train. Supporting facility utilities. Now these are main supporting systems of facilities are. That's another point that to think on. Certainly, utility systems comprise boiler feed water utility. It is boiler feed water, steam and condensate systems, raw, demineralized, potable and service water systems, raw, demineralized, potable and service water systems, power generation and distribution, cooling water system, chilled water and closed cooling water system, instrument and tool air system, nitrogen system, heat transfer fluid system, aqueous ammonia system. So these are supporting utilities, whereas these were base oil units, and you can say offshore download liquid processing, oil processing. So as liquid processing as oil processing, and then there is no base oil, and now supporting systems or utility systems. You can see then cooling water system, instrument and tool, air system, nitrogen system, heat transfer fluid system, aqueous ammonia system. These are utility systems. Utility systems shall be designed to allow stand-alone operation of GTL, gas to liquid complex. Steam and gas turbines be provided for shaft power and generation of electrical power. Steam shall be generated in synthesis section, thereby effectively utilizing exothermic heat of process reaction. Auxiliary boilers and gas turbines. Auxiliary boilers and gas turbines with heat recovery steam generation, HRSG, heat recovery steam generation shall be included to facilitate black start capability to enhance reliability of steam and power system. Cooling shall be done principally by air, but cooling water may also be used where appropriate. Steam is principal heating medium, but fired heaters and a heat transfer fluid system shall be provided for specific applications. Now supporting facilities. This was your utility system, supporting facilities, utilities, and this is supporting facilities are storage and off-sites. Storage and off-sites. Storage and off-site systems comprise relief and blowdown system, including flares, drainage, collection and primary treatment, effluent water treatment, sour water stripper, flushing oil system, storage and loading facilities, including on-site product storage, slopes and intermediate storage. In general, plant condensate blended with naphtha and GTL products shall be stored on site and transported to RLC harbor for shipping. Field condensate shall be stored in an on-site as well as an off-site shipping tank prior to export via RLC harbor. LPG shall be transported directly to RLC facilities for refrigeration, storage and export. Liquid sulfur shall be piped to common RLC facilities. Now, design basis. Design basis is also very important to understand. After all, it's like feed, it's feed, nothing else, Design basis, mechanical equipment. Table of contents, let us say general, list of codes, specifications and standards, design basis, mechanical equipment selection, spare parts, shop testing. These are mechanical equipment related. Now what is there to think of? Mechanical equipment. Purpose of this part is to provide design basis for all mechanical equipment, rotating equipment and static equipment, both on scheme and its various requirements, intended to be employed on plant facility for successful operation and functioning of plant processes during entire life of plant facility. Purpose of this part is to provide design basis for all mechanical equipment, may be rotating or may be static, on scheme and its various requirements, intended to be employed on plant facility for successful operation and functioning of plant processes during entire life of plant facility. It shall be used for verification of selection and detailing, sizing of equipment for procurement, engineering, while developing EPIC documents. Plant facility design and installation shall consider 100% equipment redundancy. Plant facility design and installation shall consider 100% equipment redundancy where applicable. 100% availability of plant. 100% availability of plant. Equipment selection to ensure 99.7% reliability. Environmental conditions. Packages and equipment shall be suitable for outdoor installation in salt-laden, saliferous and highly corrosive atmosphere, prevalent open coastal area. Plant facility design and installation shall consider 100% equipment redundancy where applicable, 100% availability of plant equipment selection to ensure 99.7% reliability, environment condition. Packages and equipment shall be suitable for outdoor installation in salt-laden, saliferous and highly corrosive environment, atmospheric. Package equipment shall be suitable for outdoor installation in salt-laden, saliferous and highly corrosive atmosphere, prevalent at open coastal areas. Basic engineering data developed shall be applied for development of feed, documents. Design life and experience. Mechanical equipment and associated auxiliaries shall be suitable for specified operating conditions, including certain upset, startup, shutdown and emergency. Be designed and constructed for minimum service life of 30 years with equipment providing at least 2 years of uninterrupted continuous service, while first major overhaul requirement should not occur before 10 years, being a design criteria. Vendor experience for previous supply of at least two validly similar design equipment and proven track record of at least 2 years trouble-free running history. So you can say 2 years of uninterrupted continuous service, while first major overhaul requirement should not occur before 10 years, being a design criteria. Vendor experience for previous supply of at least two validly similar design equipment and proven track record of at least 2 years trouble-free running a history history, experience in continuous in conditions similar to those project conditions shall be applicable. List of code specification standard, these are there. This I'm just reading, not going to details of that, because list of codes changing, and this is very old, but you can say some gastric, I think. Main cooling water pumps, associated auxiliaries, main cooling water pump, associated auxiliaries, and other mechanical equipment we designed and manufactured in compliance with requisition. Documents listed in requisition and applicable specification. Data sheet included elsewhere for consideration as part of feed document with compliance to following. Applicable codes, standards, and reference documents. That's must one. Equipment specification lists applicable international codes and standards. There's applicable codes, standard, reference documents, equipment specification lists applicable international codes and standards. Reference to demanded standards or codes shall mean latest edition of standard or code, including addenda or supplements or revisions laid thereto as an effective date of contract. Project documents, general project design basis, technical specification of vibration monitoring system, piping material specification, company specifications, lifting equipment, technical regulations, RA pressure vessel design and fabrication. RA above ground welded stores, tanks, RA pressure vessel, RA air cool heat exchange design and fabrication, plate heat exchanger design and construction, RA piping general designs, and diesel engine driven generator, equipment identification and tag numbering, standard specification for painting. We can say RA above ground welded storage tank, RA pressure vessel, RA air cooled heat exchanger design and fabrication, plate heat exchanger design and construction, RA piping general design, diesel engine driven generator, equipment identification and tag numbering, standard specification for painting, and now RA piping general design, diesel engine driven generator, equipment identification and tag numbering, standard specification for painting and wrapping of metal surfaces, company standard applicable, to other disciplines be listed in individual equipment specifications and data sheet included elsewhere for consideration as part of feed. Say RA. Now these codes I'm not going to give because there's no meaning. Now what to do? The main is principle to be adopted during selection and specification of prime equipment and equipment within proposed package can be summarized as follows. Design life of facility being 30 years, high availability, standard proven equipment model, safe to operate and maintain, typical subjects to be addressed, considered during equipment selection, and final preparation of purchase acquisition are addressed in following sections. Nameplates indicating major design parameters, specified parameters be screw attached to equipment. Nameplates shall be in stainless steel 316 material. Equipment standardization. Equipment standardization. Design of rotating mechanical equipment shall ensure high equipment availability and maintainability. Effort shall be made to standardize spares stocking by minimizing variety of makes and type of auxiliary equipment used within package. This standardization be applied so far as it doesn't interfere with selection of an optimal condition or solution for specified operating conditions and duly considered equipment to minimize spares stocking. Noise. Equipment design shall meet noise level 85 dBA at 1 meter specified in company standard. Its supplier's full responsibility to ensure that noise level of supplied equipment, including drive equipment as a combined unit, shall not exceed maximum allowable as specified in project HSE plan. Effort shall be made to select equipment with low noise level where it's not feasible despite best design available acoustics enclosures and or acoustic insulation shall be provided. Where it's not feasible despite best design available acoustic enclosures or acoustic insulation shall be provided, and you know what is acoustic, related to sound. Supplier shall submit estimated noise level and consider advice measures that would be applied when equipment noise level exceeds to noise level and then you can say instrumentation controls. Equipment supplier shall indicate all required package, equipment, auxiliaries, control for safe operation of equipment. Instrumentation for communication with DCS shall be included to comply with requirements specified in respective equipment specifications, datasheet and process ITs. Equipment covered. Equipment covered. This design basis covers requirements for following equipment: main cooling water pump vertically suspended, submerged pump and mixed flow seawater service pumps, complete with electric motor drive, VSD transformer, local control panel and associated auxiliaries. Centrifugal pumps general service includes hypochlorite dosing pumps, dilution pumps, etc. Submersible motor pumps, portable. Portable includes sump pump and dry water pumps. Fire water pumps according to NFPA 20. Fire water pumps. Instrument air compressor and dryer package. Centrifugal fan at hydrogen disengagement tank of chlorination plant. Electric operated cranes, semi-portal cranes, pump house, mechanical plant, receiving basin, workshop, warehouse and piping manifold area cranes. Fixed bar screens, cooling water, common raking facility, rotating drum screens, stop logs, intake and receiving basin, emergency diesel generator set, vessel and storage tanks, electrochlorination plant equipment. Equipment selection. Main cooling water pump set. By electric motor driven through VSD, vertically suspended submerged end mixed flow seawater service line shaft pumps with right angle discharge head shall comply with project specifications requirements, HISS standards and in general compliance to API 610 standards where applicable for this service, such as pump rotor dynamics, vibration levels, line shaft and thrust bearing design criteria, etc. Offered vibration monitoring system for pumps motor shall be in compliance with API 660 recommendation. Pump data sheets shall address pump drive train requirements, VSD's local control panels and complete electric setup shall be provided by pump. Vendor single point responsibility for tender scope. Vertical centrifugal pumps handling the liquids whose vapor pressure is below atmospheric pressure can be provided with gland packings suitable for such service. Pump line shaft bearings shall be service fluid lubricated, however, supplier incorporate pump bearing design or operation a strategy that should take care of start of scenario of standby pumps that would be with dried up bearing. Pump shall be sharp assembled to a maximum possible extent to consider minimum site assembly work and shipment limitations. All pump houses all pump houses being located in non-hazardous area, while such pumps are operating in very corrosive environment, that is salt laden sea, mist, dust, winds, etc. Flexible coupling shall be selected for every duty by main cooling water pump sets vendor. Coupling guards shall be made from non-sparking materials. So I think we should take it later. There's so many, and I have to talk of something else also. We'll take this later now because it is different. I'll talk on SCMs, which is also important from this viewpoint. So I'll come back in 2 minutes and talk on this, which is also very important. Supplementary cementing materials for construction, of course, very significant. Let's take some part of this in our talks. Okay. So we continue like this. Supplementary cementing materials, SCMs. Supplementary cementing materials, we talk like this. Supplementary cementing materials are those which, when used with Portland cement, contribute the properties of hardened concrete through hydraulic or pozzolanic activity or by both. Supplementing cementing materials are those which, when used with Portland cement, contribute to properties of hardened concrete through hydraulic or pozzolanic activity or by both. Typical examples of such materials are PFA, fly ash or pulverized fly ash, ground granulated blast furnace slag, GGBFS or GGBS, silica fumes and natural pozzolanas. SCMs, in short we call them supplementary cementing materials, are well developed materials and used properly while mixing concrete. Hardly a site is left where SCMs are not used. Reason that we can say are follows. Every kilogram of Portland cement, when used, releases about 1 ton carbon dioxide into atmosphere. If we replace partially the cement, Portland cement with cementing materials, supplementary cementing materials, we can reduce greenhouse gases emissions proportionately, resulting in more green concrete through reduced energy consumption, which is required to produce cement, with avoidance of process emissions related to limestone calcinations. Additional benefits include minimization of water disposal by using such materials for landfilling with these industrial byproducts, causing lesser pressure on natural resources, such as reduction in limestone consumption, use for production of cement by replacement of part of cement with SCMs. While SCMs are used judiciously, improved concrete properties and durability can be achieved. Also required for sustainability of available energy for future generation to come. And we can define this as sustainable development demands that state-of-art technology should be developed in such a way that current requirements are met, while preservation of energy should also be left available to be used by future generation without difficulty or causing unbalancing to natural equilibrium of energies. It's true, yet thorough knowledge of technology requires development to understand certainly all aspects of producing durable concrete. Durable concrete is very important term. What's understood by article meaning of term durability being how far hardened concrete can serve a structure, keeping intact all its inherited properties at production time, while accepting effects imparted by material hysteresis, including its further adverse impacts on reinforcement or other material constituents ingredients. Supervision and quality requirement. Assurance is also necessary on concrete production, from plants or site mixers to site locations which part has been missing or undervalued in many areas of globe. Thorough knowledge of concrete durability or other properties require good understanding by personnel working on concrete. In particular, qualified site supervisors, semi-qualified site supervisors, site consultants, and site foremen must be trained to understand as well as apply quality demands to achieve durable status of concrete. In fact, concrete technology has widened its scope to unlimited areas, unlimited levels. Yet, they stem from clear understanding by common applicants who should be responsible for concrete application, resulting in deliveries of substandard concrete, even in areas where good, skilled supervisors are available. It's also suggested that engineers should strive to have on-front experience to understand concrete technology, in addition to having understanding of office and laboratory activities. I'll keep this file off now, so then you can say I cannot take this, no problem, we'll continue this also. I know we are talking about this, so let's stay on this and close our files. Fly ash. Fly ash, we know, everybody knows about that. It's nothing very new. Fly ash is finely divided residue, finely, very finely divided residue resulting from combustion of pulverized coal, that is carried from combustion chamber of a furnace by exhaust gases. Fly ash. Residual material it is and results from combustion of pulverized coal, that is carried from combustion chamber of a furnace by exhaust gases. Pulverized coal, it's also an important point. What is that? Let's have a look on this before going down. Hold on please, I'm just getting out a print for your reference. We should know when we talk something is better. Here you can see that okay. Pulverized coal. Now in this there are certain terms which are energy, engineering, boiler, gasification, biomass, naturally. Now fossil fuel power plants technology. Fossil fuel power plants technology. Materials for ultra supercritical and advanced ultra supercritical power plants. It's 2017, recent one. Coal-fired power generation plants. Coal-fired power generation plant. Let me close other files so that undue weight is not created on this. Okay, so we can say now it's just file from internet. This is coal-fired power generation plants. A coal-fired thermal power station is a power plant in which prime mover is steam driven. Water is heated turns into steam and spins a steam turbine which drives an electrical generator as schematically shown. After it passes through turbine 1 to 3 stages, steam is condensed in a condenser and recycled to where it was heated. This is known as Rankine cycle. You can see this. Steam to turbine, and it's coming from here, unused heat, and this is here fuel in, and this is pump. Figure steam cycle is at heart of coal fired power plant efficiency. The steam cycle is at heart of coal fired power plant efficiency, and this is turbine, electricity out, steam to turbine, electricity out, and it's heated here, and we get from this fuel in, and this is unused heat. This doesn't go to turbine but goes back again, and this is Rankine. Steam cycle is at heart of coal fired power plant. What it says again, a coal fired thermal power station is a power plant in which prime mover is steam driven. Water is heated, turns into steam and spins a steam turbine which drives an electrical generator as schematically shown after it passes through turbine. Steam is condensed in a condenser and recycled to where it was heated. This is known as Rankine cycle. Efficiency of Rankine cycle can be increased by introducing reheating of steam after passage of high pressure turbine. Reheating not only improves plant efficiency but also reduces excessive moisture problem in low pressure turbines. Reheating is commonly used in modern steam power plants and for USC plants or AUSC plants. Double reheating, wherein additional reheating after second turbine occurs, is adding another benefit to plant efficiency. Schematic and TS diagram of ideal reheat Rankine cycle. You can see this ideal Rankine cycle. Nuclear heat source goes to stage 1. Reheat, say it goes here. W is pump. Okay, this says it goes, let's say here. Nuclear heat source goes here. Stage 1 turbine goes back to reheat, and stage 2. So stage 1 is here, goes here, it also goes there, goes here and heat, and again goes here to stage 2, and then back to 3 here, condensing radiator, and this is generator, and then electric power, and this is condensing radiator and the pump, and like this. Ideal Rankine cycle. And this entropy, you know entropy, what is entropy is? Rankine cycle with reheat, and that's entropy as it was in applied thermodynamics I studied, and temperature is here, entropy and temperature. You can see higher temperature up to here, and then coming down So you can say, if you compare it to that one, you see number one is air, this temperature range. Then though 2 is come down, temperature comes down, then it goes to 2 dash, again down little, and then to 3, which is air, condenser radiator. Then comes here number 4, which is air, again 4 here like this, and goes to 5. This is Rankine cycle with heat. Ideal reheat Rankine cycle differs from simple. Ideal Rankine cycle in that expansion process takes place in 2 stages. In first stage, high pressure turbine, steam is expanded isentropically to an intermediate pressure and sent back to boiler, where it is reheated at constant pressure, usually to inlet temperature of first turbine stage. Steam then expands isentropically in second stage, low pressure turbine to condenser pressure. It's important paragraph. Ideal reheat Rankine cycle differs from ordinary one, simple one. Ideal Rankine cycle expands in this expansion process affects in 2 stages. In number 1 stage, first stage, high pressure turbine, steam is expanded isentropically to an intermediate pressure and sent back to boiler, where it's reheated at constant pressure, usually to inlet temperature of first turbine stage. Steam then expands isentropically in second stage, low pressure turbine to condensate pressure. Energy efficiency of conventional thermal power station, considered soluble energy produced as percent of heating value of fuel consumed, is typically 33% for subcritical up to 48% for most recent ultra supercritical plants. As with all heat engines, their efficiency is limited and governed by laws of thermodynamics. I just said that. Thermodynamics. And also said, what was this? Yes, it was where is it going? Just a minute please, I just thought. Isentropically, just a minute please. Isentropical. In thermodynamics, an isentropic process is an idealized thermodynamics process that is both adiabatic and reversible. Work transfers of system are frictionless and there is no net transfer of heat or matter. Such an idealized process is useful in engineering as a model of and basis of comparison for real process. So understand? Thermodynamics, isentropic process is an idealized thermodynamics process that's both adiabatic and reversible. Work transfers of system are frictionless and there is no net transfer of heat or matter. Such an idealized process is useful in engineering as a model of and basis of comparison of heat process, real process. So that's what that's now. I took off that file of this better, took off that file, no meaning of that file. The rest goes, I close this. Okay. So we can say, as we discussed, energy efficiency of conventional thermal power station considered saleable. Energy produced as a percent of heating value of fuel consumed is typically 33%, for subcritical up to 48%, for most recent ultra supercritical plants. As with all heat engines, heat engines, their efficiency is limited and governed by laws of thermodynamics. By comparison, most hydropower stations are about 90% efficient. Most hydropower stations are 90% efficient in converting energy of falling water into electricity. Greatest variation in design of thermal power stations is due to different fossil fuels resources generally used to heat water. Some prefer to use term energy center because such facilities convert form of heat into energy into electrical energy. Certain thermal power plants also are designed to produce heat energy for industrial purposes of district heating or desalination of water in addition to generating electrical power. Globally, fossil fueled thermal power plants produce a large part of man-made carbon dioxide emissions to atmosphere, and efforts to reduce these are varied and widespread. A pulverized coal-fired boiler is an industrial or utility boiler that generates thermal energy by burning pulverized coal, also known as powdered coal. A pulverized coal-fired boiler is an ideal industrial or utility boiler that generates thermal energy by burning pulverized coal, also known as powdered coal or coal dust, since it is fine as face powder in cosmetic makeup that is blown into firebox. Basic idea of a firing system using pulverized fuel is to use whole volume of furnace for combustion of solid fuels. Coal is ground to size of a fine grain mixed with air. Coal is ground to size of a fine grain mixed with air and burned in gas flow. Biomass and other materials like waste can also be added to mixture. Coal contains mineral matter that is converted to ash during combustion. Coal contains mineral matter that is converted to ash during combustion. Ash is removed as bottom ash and fly ash. Bottom ash and fly ash. Bottom ash is removed at furnace bottom. This type of boiler dominates electrical power industry. Providing steam to drive large turbines. Pulverized coal produces about 50% world's electric supply. Concept of burning coal that has been pulverized into fine powder stems from belief that if coal is made fine enough, it will burn almost as easily and efficiently as gas. Feeding rate of coal according to boiler demand. Feeding rate of coal according to boiler demand and amount of air available for drying and transporting pulverized coal fuel is controlled by computers. Pieces of coal are crushed between balls or cylindrical rollers that move between two racks of races. Raw coal is then fed into pulverizer along with air heated to about 330 degrees Celsius. Important one, let us see. Feeding rate of coal according to boiler demand and amount of air available for drying and transporting pulverized coal fuel is controlled by computers. Pieces of coal are crushed between balls or cylindrical rollers that move between two tracks or traces. Raw coal is then fed into pulverizer along with air heated to about 330 degrees Celsius from boiler. As coal gets crushed by rolling action, hot air dries it and blows usable fine coal powder out to be used as fuel. Powdered coal from pulverizer is directly blown to a burner in boiler. Directly blown says powdered coal from pulverizer is directly blown to a burner in boiler. Burner mixes powdered coal. Burner mixes powdered coal in air suspension. Burner mixes powdered coal in air suspension with additional preheated combustion air and forces it out of a nozzle. Burner mixes powdered coal in air suspension with additional preheated combustion air and forces it out of nozzle. Similar in action to fuel being atomized by a fuel injector in modern cars. Under operating conditions, there is enough heat in combustion zone to ignite all incoming fuel. Pulverized coal powder plants are broken down. Pulverized coal power plants are broken down into 4 categories with operating temperatures and pressures as a function of stream temperature and pressure. Subcritical pulverized coal plants blow critical point of water 540 degrees Celsius and 170 to 220 bar have an operating efficiency less than 38%. Supercritical pulverized coal plants operate above critical point at 250 bar and 615 degrees Celsius with efficiency up to 42%. Ultra supercritical pulverized coal plants operate above critical point at 300 bar and 62 degrees Celsius with efficiency in 40 to 46% range. Advanced ultra supercritical pulverized coal is next generation targeting operating efficiency greater than 50% with steam temperature in range of 700 to 760 degrees Celsius and pressure up to 350 bars. This is temperature versus pressure MPa. Water equilibrium diagram, and that you can see shown 0 to 750 degrees Celsius, and here pressure is 1 to 0.1 to 30, and this line shows critical point. In this case you can say here saturated vapor pressure curve. Saturated pressure curve, this goes means if pressure is rising, here temperature is rising. Temperature is rising and pressure is rising, this saturated vapor curve. This is solid ice here because pressure is more, temperature is less. This is liquid water, pressure is more, temperature is rise, and here you can say this is water area, and this is you can say ultra supercritical water. Supercritical water here with temperature and pressure both are higher, and the security point at temperature 374 degrees Celsius with pressure 22 MPa, and this is gas streams. Yeah. So solid ice, liquid water, saturated vapor pressure curve, supercritical water, and gas stream. This is water equilibrium diagram. Overview, science direct topics. Then supercritical power plants were in service in late 1950s, but technology did not really take off due to problems of reliability, especially from metallurgical aspects. Denmark was first in Europe to build supercritical plants, but Germany followed very soon after, and later on also Italy plant, ultra supercritical plant with extreme temperatures around 600 degrees Celsius is now considered state of art in Europe. That is, supercritical plant with extreme temperature around 600 is now considered state of art in Europe, Japan and China, whereas United States has still not implemented this as concept. It was development of steel grade 91 and later 92 for heavy section tubular components and derivatives for cast and forged components that made this possible. Here, main advantage between subcritical, supercritical and USC units and reason for a higher pressure operation is increase in thermodynamic efficiency. Main advantage between subcritical and supercritical and USC units and reason for higher pressure is increasing thermodynamic efficiency of Rankine cycle. ऊपर जाएगी तो बटन दबा दिया, लाइट चली गई, उसकी आवाज़ आ रही थी ऊपर से, उसका बटन दबाना पड़ेगा ऊपर, अभी गई है. Light is a problem here, in fact. Problem is that, what to do. I'll save this file. Let me see what's balance here in this. We can discuss later on. It's a very important one. I like to share it, all information whatever we have on the site. It's on website. So I like to discuss this as much as possible. So I'll save this. I like to save it now. Also 640. I'll save it. Take it later on now. What to do? Let us see if we can do something. How long it goes. It's good, not a bad, good one, good information here. हाँ आ गई होगी उसमें, हाँ ठीक है आ गई। 2 मिनट के लिए लगवाते हैं, संग तंग कर देते हैं। All right, so